Hi, this is Prasanna from Wave Academia. Welcome to Electronics Edition. In this video, we are going to discuss how to develop a differentiator using op-amp in Matlab. If you look at this circuit diagram, this is the circuit which represents the differentiator using operational amplifier, which consists of two important elements, one capacitor and one resistor. The capacitor is connected in the input side of operational amplifier, whereas the resistor is connected in feedback path of operational amplifier. We know that if you differentiate a sinusoidal waveform, which will give you cosine waveform. If you differentiate a square waveform, it will give you pulses like this. Similarly, if you differentiate a triangular waveform, it will give you square waveform. So this is what we are going to discuss by today with the help of Matlab. So what about the elements I am going to use in the Matlab, which belongs to Simscape physical systems. Okay. Now I am straight away moving on to the Matlab. We will discuss how the differentiator circuit is working in Matlab. So very important note that you have to feed your inputs in the inverting terminal of operational amplifier. There is a negative terminal. Now I'm straight away moving on to the Matlab. First of all, I will let you know where to pick the elements. Go to library browser, go to Simscape, from there go to foundation library, go to electrical, there you are having electrical elements, sensors and sources. Go to electrical elements. First I need a operational amplifier and I need a capacitor, I need a resistor, and then I want to measure both inputs as well as output voltage. So I need two sensors, and then in my first part I'm going to use a AC voltage source, that is a sinusoidal signal, as the input. So we know that the differentiation of sinusoidal signal will give you cosine wave. So it will be the first part is AC voltage source. I want to measure both input as well as output voltage. Now I am connecting the input voltage source with the input sensor, voltage sensor. And you are having operational amplifier. So make sure that you have to flip the operational amplifier upside down. There is no shortcut key to flip it. Right click on it, go to format, go to flip block, click on up down. So you can straight away connect the AC voltage source with the operational amplifier negative terminal. We know that as per the circuit in input side, I am going to place the capacitor. Now it is connected, and I need a electrical reference. So this negative is connected with electrical reference. Similarly, this resistor is connected in feedback path. If you want to measure the output voltage, you can connect it like this. So for running this system, you need a solver configuration, which is mandatory, otherwise it throws you error. Now I'm going to connect the voltage sensor output with the scope. We need a PS to Simulink conversion unit. Output is connected with the the second terminal. Similarly, input is connected with the first terminal. Now the system is ready. You have to feed the inputs. Whatever the stop time I'm using, it's 0.02 seconds. So go to AC voltage source. Make sure that the peak amplitude is 1 and the frequency is, let it be, it's 1000 Hz. Similarly, go to capacitor. Whatever the capacitance value I'm using in my simulation is 0.01 microfarad, and let the series resistance 1 e power minus 6 ohms. Go to resistor. Whatever the resistor value I'm using, it's 10,000 ohms. So now the system is ready. If you integrate a sinusoidal waveform, if you differentiate the sinusoidal waveform, it will give you cosine waveform. If you integrate it, it will give you minus cosine. Okay, now we are discussing only differentiator. Run it. Go to the scope. So if you look at this, the black one is input, it's a sinusoidal waveform, and the red one is its output. It will give you a cosine waveform. You can see. This one is sinusoidal input. This one is cosine output. Similarly, you can feed any kind of inputs. Now I will tell you how to feed input of a square waveform with a repeating sequence. You can take an element called repeating sequence. Instead of AC voltage source, I am using this repeating sequence. So this will act as a triangular waveform. See, as of now, this repeating sequence will give you a sawtooth waveform. You can change the terminals parameters, double click it, go to time values, whatever the stop time I am using, 0.02 only. So let it be the time values as 0, and let it be the last value as 0.01, and middle value is 0.005. So output is 0, 1, 0. You can see this will give you triangular input. Similarly, you cannot straight away connect this repeating sequence with the input of this differentiator circuit because this is not an electrical signal. So I need one more component called constant voltage source. Similarly, this one belongs to Simscape physical systems, whereas this one belongs to Simlink. I need a Simulink to PS converter. And the output of Simulink to PS converter is given as input to the constant voltage source, which will give you an electrical signal. You can straight away connect this with a operational amplifier. So whatever it is, it's a triangular input. So what is the output of triangular waveform? this will give you square output. Now if you run the system, the input is triangular, whereas the output is square waveform. You can see this. This is the input, and you will get a square waveform as output. Similarly, you can give square input. How to give square input? Now I will tell you how to use a component called signal builder. Okay, so whatever the stop time I'm using, it's only 0.02. So go to signal builder. Go to access, change the time range from, so whatever the default, it is showing maximum of 10 seconds. It will be, it's a 0.02. Okay, now go to signal, go to signals, go to new, go to customize signal. There you can feed your inputs. So make sure that the time values and y values are equal. If it is not equal, definitely it throws you error. Okay, I'm starting with 0. You can take these as your reference value. Zero point 004, 0.004, 0.006, 0.006, 0.008, 0.008, 0.01, 0.01. Okay, this is enough, I think so. So count the number 1, 2, 3, 4, 2, 4, 6, 8, 10. Total I'm having 11 values. Okay. So similarly I have to feed 11 y values. 0, 0, 1, 1, 1. Now totally 11 values are there. Click OK. This will give you, so if you look at this, take the second signal, this will give you sinusoidal, square input. Delete the first one. Of course, whatever the value I am choosing, it's only for 0.01 seconds. Okay, so accordingly you can change the stop time, close it, change the stop time as 0.01. So similarly, we know that the signal builder is a simple signal. You have to connect it with similar to PS converter. Again, a control voltage source. The output of control voltage source only will give you electrical signal. Okay. Now, if you run the system, you'll get the differentiated output of square waveform. What is differentiated output of square waveform? Which will give you a pulse like this. See, to zoom it, only this portion. I'm just zooming this minute portion. Get a pulse. Okay. So it's a zoomed view of response. You will get a pulse like this. So this is the differentiator circuit. You can do the same kind of thing with any other inputs. You can easily analyze how the differentiator is working. I hope this video will give you a greater insight of how the differentiator is working with the help of amplifier in Matlab, how to simulate the same thing. Okay. Kindly subscribe to the channel. Thank you. If you have any queries, please drop a mail to this mail ID. Thank you.